here is the example. Insertion and deletion in binary search tree. For this example, first how to insert this in binary tree, this data in binary tree. Let's see the first insertion. First node. This is the first value we have to consider as root node in binary tree. While we are constructing a binary search tree, we have to consider first value as a root node. 15 is the root node. Next 10. 10 is the less than or greater than? Less than of the root node. Root node is the 15 and next value is 10. 10 is less than the root node. So we have to consider here. It is the left side. Then 5. 5 is less than the root node, and here it comes, and this is also less than the 10. 5. Next 20. 20 is greater than root node. Here 20. Next 8. 8 is less than the root node. Here 10. 8 is less than the 10. Again here it is a greater than 5. So we have to write it as right side 8. Then 18 we have to insert. 18 is greater than the root node. Then it comes into right side node. Then it is less than the 20 node 20. So we have to write left side 18. Later we have to insert 4. 4 is less than the root node, and it comes here. So 4 is less than the 10 node. Again it is less than the 5th node. So it comes here 4. Next 25. 25 is greater than the root node. Then it comes into right side. Again 20. Here it comes a 20 node. So we have to insert 25. So greater than this node. 25. Next we have to insert 2. 2 is less than the root node, and it is also less than this 10 node, and we have to come here. It is also less than, and it is also less than the 4th node. So it comes here. Right? Next we have to insert 35. 35 is greater than the root node 15, and here it is the value 35. 35 we have to enter into the right side subtree. So 20. 30 is greater than 20. We have to come right side. Here it is 25. 25 is less than the 35 node. Then we have to come here right side of the 25 node. So we have to write here 35. Next we have to insert 23. 23 is greater than root node. This enters into the right side subtree. 20 is less than the 23. So it is a greater than, 23 is greater than the 20. So here it comes in this node. Here it is 25. 25 is greater and 23 is less. So we have to write it as a left side of the 25 node. Here it is 23, and this is the insertion in binary search tree. Insertion is finished. Next, deletion. We have to see. In deletion method, we have 3 rules. One is 0 child. Second one is 1 child. third one is 2 child. 2 child. In this deletion of a node, we have insertion is finished. So we have to delete a node from this. So in this we have 3 conditions, that is 0 child, 1 child and 2 child. So in first condition 0 child. So if we consider 23, 23 has no child. 23 has no child. So if we say delete 23, so 23 having no child, so simply we can replace it. Simply we can replace it. There is no big deal in this. In second condition, 1 child. If we have to delete a node having 1 child, then we have to replace that node. For example, if we have to delete 4, we have to replace with this node with 2. Now here we have to replace 4 with 2, and this is the process. Third condition, having 2 childs. In this, when we take condition 2 child, a node containing 2 child, a node containing 2 child, a node containing 2 child. When we have to delete a node containing 2 child, then we have 2 conditions, that is in order predecessor and in order successor. Now we have to delete 15 containing 2 children. Here in order predecessor we can use or in order successor to replace this node. If we take in order predecessor, in order predecessor, this when we consider left subtree, in this we have to choose the node having the largest value. Largest value we have to choose to replace this node. When we consider this part, we have to choose the value lowest value. In this we have to choose the lowest value to replace this value. So let's see how we can draw a binary search tree considering in order predecessor and in order successor. In order predecessor and in order successor. When we have to delete a node 15 containing 2 children, we have in order predecessor and in order successor. Now let's see the diagram. In order predecessor means what I said, we have to take the value that must have greater. We have to consider, when we consider the predecessor, we have to take the greatest value from this left subtree. We have to take the greatest value to replace it. And in this which is the greatest value? 10. 10 is the greatest value. We have to replace 10 with the 15 in order predecessor. So the diagram is here. It is the in order predecessor. We have deleted 15. When we see here, there is no 15 in this. We deleted 15 by replacing greatest value of left subtree. Here it is 10. 10 we have replaced in root node. Okay. Now in order successor, you have to take the lowest number to replace it with 15. Which is the lowest number in this? 18. 18 is the lowest in right side subtree. 18 is the lowest one. We have to replace 18 with 15. Let's see the in order successor diagram. And this is the in order successor. We have replaced lowest value in right subtree with the root node. This is the predecessor. Predecessor is nothing but we have to take the greatest value in, we have to select the greatest value in left subtree to replace the root node. In order successor means we have to replace the greatest value from right subtree. And this is the topic about insertion and deletion in binary search tree. BST is nothing but binary search tree. And this is the insertion and deletion. In deletion we have 3 conditions: 0 child, 1 child, 2 child. In 2 child we have in order predecessor, in order successor. And this is the examples for that. Thank you.